A sound from space? When up there in space, no one can hear you talk, laugh, or scream. Or at least that's how the saying goes. People can't hear anything in space due to its condition. Still, if you have the right conditions, like the hot gas that surrounds the black hole located at the center of Perseus, space can be quite noisy. That's the galaxy cluster 250 million light-years away from us. Researchers caught an actual sound of space, waves rippling through the plasma gas in Perseus. They first realized black holes generate acoustic signals in 2003, but this is the first time they brought these signals to the human ear, and wow, this sounds terrifying. Canyons filled with liquid on Titan. Almost a decade ago, NASA spacecraft discovered deep canyons on one of Saturn's moons, Titan. They're about a half-mile wide and they kinda look like the Grand Canyon, but they're filled with liquid hydrocarbon. This was the first time we came upon evidence of canyons and channels filled with liquid on Titan. Our solar system is full of small particles and bigger rocks that circle the sun, the same way as planets. Sometimes it happens, some of them change trajectory, which is why falling pieces of debris strike the planets. Most of the meteorites and comets originate in our solar system. Some from the asteroid belt between Jupiter and Mars, while others come from the Kuiper belt, that's located beyond the orbit of Neptune. But 5 years ago, scientists found something unusual, a red, elongated floating space rock called Oumuamua. It could be more than 3,000 feet long, but its size still wasn't the most impressive part. It was the first interstellar object we saw passing through our solar system. It means it formed and came outside of it. It was traveling way faster than asteroids and comets from within our solar system. No one knows where this weird object came from. Many, many years ago, when it started its journey and sailed away from its parent planetary system, the stars weren't in the same position as they are today, so it's hard to pinpoint where Oumuamua ran away from. The rock could have been on its journey for billions of years. Solar termination events. Our sun is not just a flaming ball of gas we see in the sky. It's actually a pretty complex network of towering plasma fountains, magnetic fields, and blobs of unusual matter 500 times bigger than our own planet. And then there are solar termination events. When it comes to its activity, our sun goes through a natural cycle of troughs and peaks. Approximately every 11 years comes the time when the sun is more active than in other periods of the process. As the cycle goes to the end, there are fewer emissions and sunspots. That's because magnetic fields are weakened at that point, and they collide along the sun's equator. This results in enormous tsunamis of plasma. They pass across the solar surface for weeks. These are the most powerful storms in our solar system. They twist, snap, and lash out into space and seriously affect our power grid. As they wake, large spots start to form on the sun, close to strong magnetic field lines. Usually, that's when the cycle begins all over again. No one still knows why exactly they form. Also, we're not sure if this only happens at the end of the cycle, and knowing more about this could help us prepare for raging solar storms better. Tsunamis on Mars. It appears the shorelines under the Martian surface formed because of two enormous tsunamis. Mars has something that's probably the longest landslide in our entire solar system. The rocks rolled down the mountain probably billions of years ago. They fell into the water and caused a gigantic wave that rushed across the Martian landscape. As the tsunami was getting bigger, the rocks scraped all along the solid ground beneath them, and these sandy waves left their prints on the shoreline, not so close to Olympus Mons. That means it's possible the waves traveled a couple of hundred miles. This supports the theory that Mars once had an ocean hidden below its dry desert surface. Sure, Oumuamua was cool because it was the first object we've seen coming from outside of our solar system. It's past us now, so it's not possible to study it anymore. But something else came from outside our solar system after Oumuamua. A comet called Borisov. It came with a tail over 100,000 miles long. Teams got the first images of Borisov in 2019. A bright white glow was surrounding it. And that was one of the first signs where scientists realized this comet wasn't from our solar system. They tried to collect as much information as possible because they remembered how quickly Oumuamua got away. Borisov came from a freezing place as cold as the Kuiper Belt. One theory says it may have originated around a red dwarf, which is the most common type of star in our galaxy, the Milky Way. But unfortunately, Borisov was also very fast. So fast that they only managed to see it a couple of weeks before it passed by our planet. By now, it's almost out of our solar system. Finding new planets is always such a thrill, just like it was in 2017, when a group of researchers discovered Super Earth. It's an exoplanet, which means it orbits a star outside of our solar system. This one has a mass almost 3 times that of our planet, and it's only 21 light-years away. It orbits M dwarf star, and it manages to make a full circle in only 2 weeks. So that's how long the year is on this planet. It's closer to its star than Mercury is to our Sun. But M dwarf stars are cooler than our Sun, so it's possible this planet still has water. Super Earth is generally a term for planets that are lighter than ice giants such as Uranus and Neptune, yet more massive than Earth. They can be made of rock, gas, or even a combination of both. The one they discovered in 2017 is especially interesting because this type of planet can also hold some form of life. Leroy Chiao is an astronaut who commanded the International Space Station back in 2005. This one time, during his final spacewalk, some pretty unusual lights caught his eye. It looked like 5 lights flying near him. They were in the shape of a pyramid, since one light was a bit further ahead. Chiao immediately called one of the crew members who was also out there at the same time, taking a spacewalk. He asked his colleague if he saw the flying objects, but apparently he didn't. Researchers were intrigued by this story, so they examined satellite images to see if that was the thing Chiao saw. One of the options was that Chiao had seen fishing boats off the coast of South America. With bright lights, they wanted to attract squid. But since it was twilight time, the rotation of our planet may have made them appear to fly by. Neutron stars slamming into each other. After a massive star comes to its end in a strong supernova explosion, its core falls apart. Then it forms the densest form of matter we know about in the whole universe, called a neutron star. In only a couple of the first few seconds after a regular star begins transforming into a neutron star, the energy there is equal to the total amount of light all stars in the universe emit. At least the part we can observe, which is still a lot. It's hard to determine their real size, but picture it this way. The length of Manhattan with 1.5 times the mass of the Sun. If a star here were any denser, it would just collapse and form a black hole. Scientists captured 2 of these stars colliding a couple of years ago, and such impacts are extremely powerful. They create gravitational waves that lead to a ripple in space-time, but they produce heavy elements like platinum and gold.
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the Sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – Panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our Sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Joukowsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the Osiris-Rex was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, Osiris-Rex has been renamed to Osiris-Apex and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. Osiris-Apex will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. Osiris-Apex has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stefan's Quintet. This photo was also posted on July 12th. Stefan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even two moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's ring so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
The James Webb Space Telescope has recently discovered 2 candidate exoplanets, orbiting their host white dwarf stars. Those are collapsed husks of once great stars. Why is this discovery so exciting? First of all, because these alien planets strongly resemble the largest gas giants in the solar system, Jupiter and Saturn. And secondly, because this discovery might shed light on what our home solar system will look like after the sun's inevitable demise. Our sun is bound to turn into a white dwarf, and this change will most likely destroy the inner solar system all the way out to Jupiter. So far, astronomers have spotted very few planets orbiting white dwarfs. What makes this latest find even more unique is that the planets are more similar to the planets in the outer solar system, in temperature, mass, age, and orbital separation than any other previously found space bodies. It allows us to see for the first time ever what a planetary system looks like after the demise of its star. The candidate planets in question were directly observed by James Webb's mid-infrared instrument while orbiting their parent white dwarf stars. One of these exoplanets is located quite far from its star, at a distance equal to around 11.5 times the distance between Earth and the Sun. The other planet is even further away from its extinguished stellar parent, at a distance of 34.5 times the distance between our planet and the Sun. So far, scientists haven't figured out the masses of the potential planets yet, but they're estimated to be between 1 and 7 times the mass of Jupiter, which is the most massive planet in the solar system. Now, let's sneak a peek into the future. When the Sun runs out of its stellar fuel and there is nothing left to support nuclear fusion processes in its core, it will swell up into a red giant. It will happen in around 5 billion years, but nuclear fusion will continue in its outer layers, which will reach out as far as Mars, swallowing Mercury, Venus, Earth, and probably even the red planet itself. In the end, the outer layers of our star will cool, leaving behind a smoldering core. Our warm yellow dwarf star will turn into a white dwarf, surrounded by a planetary nebula made up of exhausted stellar matter. The outer planets are likely to drift outward into wider orbits after the Sun goes out. It means that the newly discovered candidate planets might have orbital separations, similar to the ones Jupiter and Saturn will have in the distant future, and if astronomers confirm these space bodies, they will provide us with direct evidence that such planets as Jupiter and Saturn can actually survive the demise of their host star. Researchers have also discovered an interesting fact about the white dwarfs themselves. Apparently, they're polluted with elements heavier than helium and hydrogen. Astronomers call such substances metals. This finding could hint at what might happen to the celestial bodies in the asteroid belt, stretching between Mars and Jupiter after the Sun goes out. Scientists have a suspicion that giant planets, like our Jupiter and Saturn, might cause metal pollution by hurtling asteroids and comets into the surfaces of their stars. The existence of such planets makes the connection between this kind of pollution and planets stronger. And since 25 to 50% of white dwarf stars experience this kind of pollution, giant planets must be common around white dwarfs. It means that 5 billion years from now, Jupiter and Saturn might be hanging out there in the darkness of space, tossing asteroids at the sun's lifeless body. By the way, about 97% of all the stars in our home Milky Way galaxy will become white dwarfs with time. That's because most stars are not massive enough to turn into anything other than white dwarfs when their lives come to an end. It means that once all the stars in the Milky Way pass the white dwarf stage and cool down into theoretical black dwarfs, the Milky Way will become pretty much invisible.
Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic Anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up. I'm not talking about a small fender bender here, I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are going to get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf, just a fraction the size of our Sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
Stars are beautiful, colorful things. There are red giants. Those are nearing the end of their lives and are on the verge of explosions. Blue stars shine in the belt of the constellation Orion, as well as other places. Yellow ones, like our Sun, are pretty ordinary. They're usually warm and stable enough to support life. But look at the night sky attentively. Do you see any green or purple stars? Nope. They're kinda invisible because of the way we humans perceive visible light. The color of a star mostly depends on its surface temperature. The hotter it is, the shorter wavelengths the light it emits will have. The hottest stars are blue or white blue. Those are some of the shortest wavelengths of light. Cooler stars are normally red and red-brown, which are longer wavelengths. At the same time, stars never send out their light in just one wavelength. It's more of a range of light. The wavelengths of light from a star peak in just one color in a bell-shaped curve. But the star emits other colors too. Human eyes have evolved to see yellow and green radiation, probably because our sun emits it mainly in these wavelengths. But a green star emits radiation right in the center of the visible light spectrum, in all possible colors. That's why such stars appear white, which is a combination of all hues. Actually, our sun emits quite a lot of green light, but we perceive it as white. Purple stars, though, are something our eyes won't ever see because they're sensitive to blue light. And since stars emitting purple light send out a lot of blue light too, because these shades are next to each other on the visible light spectrum. The human eye picks up only the blue light. When it comes to other objects in the solar system, many planets seem to have no obvious hue. Look at Venus, Saturn, or Jupiter. They look kinda bland, probably whitish at best, but there are several planets that boast very decisive colors. For example, Mars looks orange-red, Neptune is blue, and Uranus has a beautiful blue-green hue. The planet gets it from all that methane gas in its atmosphere. Meteors sometimes display a vivid green too, and look at breathtaking bright auroras. Green is the most common color of the northern lights. But not stars, never stars. The brightest star in the sky, besides our sun of course, is Sirius. It's twice as bright as its competitor, Canopus, located in the southern constellation Carina. Being the most brilliant, Sirius is very easy to identify. Probably the coolest thing about this star is that it seems to be changing its color. But we'll get to it a bit later. This star is whiter and hotter than the sun. Its surface temperature is 17,300 degrees F, while the sun's surface temperature only reaches 10,000 degrees F. When you combine the immense heat Sirius emits with its girth, 1.75 times the size of the sun, you'll understand why the star looks so bright in the night sky. Sirius has a companion star. It's called the Pup. It's a tiny but incredibly dense white dwarf with a diameter of a mere 7,000 miles. This makes it smaller than Earth. At the same time, its mass reaches 98% of that of the sun. It means that the matter inside this tiny star is squeezed very, very tightly. That's why its gravitational pull is 350,000 times greater than Earth's. A person weighing 150 pounds would weigh 50 million pounds on this star. Now, Sirius is famous for its twinkling, and since it is also the brightest star, we can observe the ever-present turbulence in its atmosphere quite well. As for the star changing its color, it has to do with the atmosphere of our planet. Pockets of air at different temperatures focus starlight this way and that like small lenses. We see it as twinkling. But since white light is made of different colors, one pocket might send some red our way. Another will send blue or yellow in totally random order. That's why it seems that Sirius twinkles in color.